Here we're going to look at configuring, static routing. And I'm not going to keep the video shorter, I'm not going to go through all of the commands. We've already got multiple tutorials, going through how to configure IP addressing and set host names and things on Catalyst switches and on routers. But just to show you, these are 2800 series routers, and these are 2950 switches. And we have 11 subnets, and we'll go through our block value and our subnetting. Also, you want to remember that when you connect your routers, that remember you have DCE and DTE. So on the DCE side of things, you have to configure the clock rate, and you might want to configure the bandwidth. DTE side, which is a default, you don't have to configure anything, but all of those interfaces have to be set up, and you want to test all that with pings. And again, there's 5 or 6 tutorials we've already gone over showing you how to do that. So I don't want to waste your time repeating hopefully what you've already watched or what you've already gone through. So we just want to focus on what are the commands and what are the technique that we need to use to implement static routing on a network like this with 11 subnets. Well, first off, before you get started, you want to figure out your IP addressing. And you can use a subnet calculator if you want, but this is simple enough that you can do it in your head if you look at the block values. So in other words, I'm going to hop on the first host over here, and if I were to look at the configuration, in this case, I'm going to use a subnet mask of 255.255.255.240. Well, if I do that, then a normal Class C address is CIDR 24, right? So the first 3 bytes are octets. Therefore, the first 24 bits are the network portion of the address. So if my subnetting mask is 240 instead of 0, then remember I'm routing Peter to pay Paul, so I'm stealing 4 bits that would normally be allocated for hosts if my block value were 1, and I'm allocating those for subnetting. So if you apply that to our formula, remember 2 to the power of x minus 2, that's 16 minus 2 is 14. So 4 bits for the subnetting gives us 14 possible subnets. That leaves 4 bits left for the hosts, which again, 2 to the power of x minus 2 gives you 14 possible hosts per subnet on each of those 14 subnets. So if you know that and you were to use the byte table and calculate or go down, your bits would be like 128, 64, 32, and 16. That last bit in the byte table, that's your lowest bit, that's your block value. And the way to calculate that, if you simply subtract the block value from the subnet mask, or excuse me, from 256, you get the subnet mask. Likewise, if you figure out what you need to add to this to get 256, that would give you the block. Well, in this case, either way, the lowest bit in the byte table is 16, or if you want to look at it another way, you could say, well, what do I have to add to 240 to get 256? 16. So that gives you the block value of 16. So that means every network is based on a multiple of 16. Okay, and we can't actually use 16. And again, there are plenty of other tutorials dealing with IP addressing and subnetting, 5 or 6. So if you need to brush up on that, you might want to go watch those before we attempt this. But if you've got that squared away, then we understand that, okay, hey, if 16 is the block value, I got to base my networks on a multiple of 16, but I can't actually use 16 as a network address because I can't have all the bits turned on or all the bits turned off, because that's either the broadcast or the network. So if that's the case, then the first usable IP address for the first network based on a block value of 16, a multiple of 16, would be 17, right? 1 bit turned on plus your subnet bit. And it's traditional, you don't have to, but it's tradition to make the lowest IP address the default gateway for any particular network. And so that being the case, I want to make 17 the gateway on my router. And that's what I did here. See the fast Ethernet connection, 17 is the gateway. And if I do that, then I just need to make sure that I configure everything to use that default gateway. And matter of fact, I want to set that here. Let me do 17 as my default gateway. And let me go. So we have 17, and then our first value, adjusted to that would be 18. Let me go over here and make sure. And then that would be 17, and then 19. Okay, so everything. This has got to point to the router, because the router's got to take care of routing any packets that aren't on a direct adjacency. a direct adjacency or a network that's directly connected to the router. And then the switch, these are just normal access ports, configured as access ports. No trunk ports here. Except for this port here going to the router, but it doesn't have to be a trunk port. I'm not using encapsulation or sub-interfaces or anything like that. But and then the switch itself, in this case, we could give it an IP address. We don't need to, but we could if we want to. And right now we're just utilizing the router IP addresses, and we're just using the switches as sort of empty layer 2 devices. But we could throw them an administrative IP if we so chose. Okay, so looking at this setup, then if that's 16, then my next network is going to be based on 32, right? Multiple of 16, so we go from 16 to 32. Well, think about it. The first valid IP would then be 33, and that's going to be the sort of a gateway. But then there's only 2 IPs in this network, 33 and 34, connecting the Galactica to the Pegasus, these routers. Okay, so we went 16, we went 32. Well, what's our next network? Another multiple of 16, it's going to be 48, which means the first valid address is going to be 49, right? And then 50 and 51, and I'd have to use 49 as my gateway. Let me double check them. Yeah, both of these should be using 49 as a gateway, the Sagan and the Babbage. Carl Sagan and Charles Babbage. Great astronomer and the father of the computer. So 16, 32, 48. Now what's our next multiple of 16 going to be based on? 64. But remember, we can't use the network address, so first valid IP 65, and then in this case 65 and 66, connecting Pegasus to the Valkyrie, this connection here. And if we want it, we're not using VLSM, but if we wanted to, that'd be a great place for VLSM, because we only need a block value of 4, right? We only need 2 IPs to connect routers. But in this example, we're not using VLSM. We will later. So we're just going to keep basing it on multiples of 16. Okay, so we went 16, 32, 48, 64, and then what's the next connection? Well, 80. First valid IP would be 81, 82, 83. Okay, so those are our first few networks. Well, what's after that? 96. Can't use the network part, so add 1. The first valid IP would be 97, and that's connecting the Valkyrie to the data list down here. And then, notice respectively they're 97 and 98. Well, what's the next network address? Again, add your 16, multiple of 16. What do you get? 112. Can't use that. That's a network address. So add 1 to it. 113 is the gateway for this network, the 112 network. And down here we have Kirk and Spock. And they should be using, let's make sure they're using, 113, which is our first valid IP for network 112. So that they're using the right gateway. Then the next multiple of 16 on our IP addressing scheme would be 128, right? Add another 16 to your 112, you get 128. Can't use that, it's a network address, so what do you have to do? You have to add 1 to it. The first available IP would be 129. 129 and 130 connect data lists and Artemis together over our serial 0/0/0/0 connection. Now, our next network is going to be what? In that case, we look at the 128 network. Again, you've just got to add in multiples of 16. So our next network is going to be 144. Can't use the network address, so we'd have to add 1 to it. So 145 is our gateway, and then 146 and 147 are our addresses. Next block, our multiple of 16, is going to be what? 160 from the 44. Can't use the network address, so you have to add 1. So the first valid IP in that network is going to be 161 to 162. That connects Artemis to the Persephone. So data list to Artemis and Artemis to Persephone. And then from the 100 and, in this example here, from the 160 network, we're going to connect to 176. Again, just another multiple of 16. When we get here, now we can't use the 176, right? That's the network address, but we need to add 1 to it. So that's 177 is our first valid IP, CIDR 28. We're going to connect, and then the next 2 IPs, respectively, would be 178, 179. Of course, making sure that we use, let me slide this over here, make sure that 177 is configured as a gateway. The Michio, the Da Vinci, Michio Kaku, Leonardo da Vinci, Oppenheimer, and Einstein. Oppenheimer being the father of the atomic bomb, and Einstein his accomplice. Okay, so that's kind of the breakdown of our IP addressing. And Anything that's a direct adjacency, a direct network, our routers know about, right? We don't really have to supply them, but anything that's not a direct adjacency, they don't know about. If we're going to do static routing, we need to supply them with that information. We need to tell them where to send those packets if those networks aren't directly connected to those routers. And we could use a dynamic routing protocol, and later we will. And on a large network, it's much easier to use a routing protocol. But this network is still small enough. It's only 11 subnets. It's not that bad. So it's still small enough to where you can implement static routing without too much trouble. It doesn't get too complicated. Now imagine if you had 50 subnets or 100 subnets. At that point, you probably want to start using EIGRP or OSPF or something like that. But static routing is great for a smaller network because it has the lowest administrative distance. Remember, it's only 1. It's the most efficient. There's no broadcast traffic, no additional traffic at all, as a matter of fact. And the routing is instantaneous. The only downside of it is it takes a lot longer to set it up, and maybe it's a little bit more complex because you have to kind of figure out all of the different network addresses and things that you have to add. So let's log into our routers and we'll look at setting up the routing tables to route our traffic. So to implement your static routing, you need to look at adjacencies and figure out what the router knows and what it needs to know. Well, what the router knows are networks directly connected to it, and that is network 16 right here and network 32 right here. It knows those two. So if we log on to the router, and I'm going to do a show IP route, notice that these are prefixed to the C. They're adjacencies, they're direct connections. So it knows about 16, it knows about 32. What does it not know about? This is what we have to teach it. Well, all of the other networks, if you think about it, 48, 64, 80, 96, 112, 128, 144, 160, and 176. All of these networks, this router needs to know where to send packets to. And this is a perimeter router on a stub network. So the beauty of it is traffic only has to flow one way. It only has to send the traffic in one direction for routes that it doesn't know. Now when we get to the middle routers, they might be a little bit more complex or a little bit trickier in how we set up the routing because traffic is going to have to flow in more than one direction. But this router, this router here and this router down here are two perimeter routers, will be pretty easy on stub networks. So if all the traffic needs to flow one way, and we know all the networks we have to teach it, which is 48 through 176, because 16 and 32 are the only ones it knows about, then where do we send it? Where do we send those packets? Where do we tell the router to route them? Well, it needs to be on the network 32 to get to one of these middle routers here. We have 1, 2, 3, 4 middle routers that are not perimeter routers. In other words, they have multiple connections and traffic going in multiple directions. But the IP address of a network or adjacency that this router knows, the closest IP is 192.168.10.34 here, CIDR 28. And that's the IP on the Pegasus. So you don't want to send it out to the direct adjacency or the IP on the router, but you want to send it to the IP of the next router that it's connected to. And that's the model that you want to follow all the way through. And to do that, how would we do that? Well, you want to go to global configuration mode, use the command IP route, and so the very first thing we're going to do, we'll just go in order here. We know about 32, we know about 16, so we need to start 48, 64, and all the way up to 176. And multiples of 16 is how we want to route it. So it's a IP route, and then it's going to be 192 and 168 and 10. And those are the first 3 octets, 24 bits of our CIDR. That's the network part. Now we have to come to the subnetting part. Well, in this case, network what? Network 48. We already know about 16. We already know about 32. The next multiple is 48. Oops, let me add the decimal there. Okay, and then the subnet mask, 255, 255, 255. That's the whole network part. There's 24 bits. And because we're subnetting on 4 bits in the last octet, our mask is 240. And then I have to tell it where to send it to. And let me pull this down. And remember, once again, that's going to be 192.168.10.34, which is the IP address of the next router attached to the adjacency, or to the interface, configured for the same network on this router. And you'll just, again, you follow that model all the way through there. So 192.168.10.34 is where we want to send the packets to. 192.168.10 and 34. Okay, and I can just hit the up arrow because I'm going to have to add quite a few of these actually all the way down. Again, I want to go from 48 now all the way down to 176 and multiples of 16, right? And the block value of 16, so 64. And the next one's going to be 80. And next one's going to be 96. And next one's going to be 112. And next one's going to be 128. Be careful, you want to make sure you add all the networks and don't leave any out, otherwise you're not going to, your traffic's not going to route. Oops, I don't want that extra 4 there either. Only problem with hitting the up arrow, I guess. 144. And an extra 4 there. And let's do the 160 subnet. And now let's end with the 176 subnet. Again, any of these packets, it just needs to know where to send them. It knows network 16, it knows network 32. It has adjacencies and interfaces configured on those networks. But all of these, we had to teach it. So make sure our IP is right. It should be sent to address 34. And make sure that our networks are right. 48, 64, 80, 96, 112, 128, 144, 160, and 176. And all looks right there. Looks good. So I'm going to exit and go back on to privilege mode and do a show IP route to look at my routing table. And again, notice I have my 2 direct connections, 16 and 32, and then all my other networks are there with static routes and an administrative distance of 1. So very efficient. Looks good. I'm going to go ahead and save it. And do copy run start. Copy start run. No, copy run start. And we'll go ahead and exit out of there. Now I want to do the very same thing on my other end router. So let's do the same thing on our other perimeter or end router. We just need to route traffic in one direction. So this one's pretty simple. And again, if you do a show IP route and look at the routing table, there's only 2 adjacencies or direct connections that it knows about. That's network 176 and 160, right? Because here on Fast Ethernet there's 176, and here the connection to the Artemis is in this case, 60. So if that's the case, then we don't have to teach it anything. We don't have to configure anything for those 2 networks, but every other network, in this case, going all the way down, every single network from 144 all the way to 16 are networks that we're going to need to teach it how to route to. But the beauty of it is, on the perimeter router, it's all going to be going to the same IP address, right? Just like here, it all went to 192.168.10.34. Here, all the traffic is going to be routed to or sent to 192.168.10.161. So it makes it pretty easy to configure the static routes. Let me go to global configuration mode and use the command IP route 192.168.10, and I need to specify, in this case, the subnet mask and the network I want to route. So we'll just work our way backwards this time. So that means we'll start at 144. Again, we know of 176 and 160, but maybe the first network we need to teach it how to route to is 144, and working back from there. So it's going to be the same subnet mask. Normally the network, 24 bits or 3 bytes, 3 octets for a class C, and then the CIDR 28 means it's a mask of 240 because there's 4 bits for subnets and 4 bits for hosts in the last byte. And then where to send it to, 192.168.10, and the IP address to send it to, again, is going to be 161 on this network. That's where all those packets will want to go, so 161. And now with that in, I can just hit my up arrow and go all the way down. So that was 144, the next network would be 128. I'm just subtracting 16 and working my way down on multiples of 16, or based on the block value of 16. So 128, so the next network would be 112. And then the next network would be 96. And the next network would be 80. And the next network would be 64. And the next network would be 48. And then the next network would be 32. And the last network that we have to teach it about would be the lowest, block value 16. Okay, and again, all that traffic's being routed in the same direction. So I'll Control Z down to privilege mode and do a show IP route. And if you look at my routing table, it's all flowing and being sent to 161, which is where we want it to go. So I'll do a copy run start, and that takes care of our 2 perimeter routers. Now we just need to configure the 4 middle ones. These will be a little bit more interesting because we have to figure out multiple ways or multiple directions to route the traffic to. So let's hop on our first middle router, the Pegasus. And if we log in, just do a quick show IP route. Now notice, because it's a middle router, we don't have 2, we have 3 interfaces or adjacencies. And what are the networks it knows about? 32, 48, and 64 in order. So we don't have to worry about those. It already knows about those and where to send traffic if it gets packets destined for those networks. So what are the networks it needs to know about? Well, let's do this way first. And the only network it doesn't have a direct connection to or adjacency is 16 over here. So we have to teach it where to send that. Well, where would it send packets that are being routed to or destined for network or subnet 16? Well, it should send them to this address, right? 192.168.10.33, the adjacency of the closest router in the direction where it's, where we want it to route those packets. So that's where we want to send it. So I'm going to go over here and I'm just going to go ahead and enter in that information for network 33. And again, I go to global configuration mode and use the command IP route. And 192.168.10, which is my network address, and then the network 16 in this case, and our subnet mask, and 192.168.10, and where to route it. And remember that that's going to be IP address 33, 192.168.10.33. That's where to send those packets. Okay. Now that's the only network that I want to route in that direction. All the other networks I need to route in the opposite direction this way. So we're going to change the direction and send it to a different IP address for the other routes. Okay, so for all those other networks that I need to teach it about, which would be what? Well, the things it does not yet know about, which are 80, 96, 112, 128, 144, 160, and 176, it has to send it the other way. Well, where would it send it? Here's the direct interface. We wouldn't want to send it here. But the IP address of the network on a direct adjacency to that router, in this case the Valkyrie over here connected to the Pegasus, would be what? 192.168.10.66. That looks a bit confusing. I tried to move them around to the IPs, but this IP down here, remember, that's network 96. That's a whole different network connecting the Valkyrie to the data list. So don't be confused there. But this is what we're talking about, is the connection here, network 64, which means the actual IP of 192.168.10.65 connecting to 192.168.10.66, the Pegasus to the Valkyrie. So we want to route all of our traffic, our remaining traffic, in this direction towards this IP, 192.168.10.66. Okay. And to do that, I can hit the up arrow. I just have to edit it a little bit more, but I want to go ahead and specify network 80. And now I need to route it in the other direction. And instead of going to 33 this way, I need to send it to 66 this way. So it's just sort of the opposite or the inverse there. Okay, and then I can leave that IP in there, and I just need to change this value for all the other networks. So I need to add 96. I need to add 112. I need to add 128. I need to add 144. I need to add 160. And I need to add 176 as my last subnet there for this Class C network. Okay, so all that traffic's going the other way. Control Z back down to privilege mode. I could do a do show IP route, but again, I try to keep, this is a 2800 series, but if you're using a 2600, I try not to use the do command, so that way it's more hopefully backwards compatible. But again, notice we have a nice administrative distance of 1. And notice that our traffic is going, you just make sure it's going in the right direction. Towards this side of the network, and the higher subnets, we want to route it to 66. I get my kicks on route 66, ha ha ha. But going lower, the lower subnets, we want to route it towards 33, towards the other side of the network. So everything looks hunky-dory. And let's just copy our running configuration to our startup configuration. And we have 3 more routers to go.